Hello Year 11 and welcome to our 5th video here for probability. We're looking at multi-stage experiments today and the product rule. Now we looked at two-stage events before and we used a table to have a look at all the outcomes there. We looked at experiments that had more than two stages and we might have used a tree diagram there to look at the outcomes as well. However, as I get more and more stages, a tree diagram becomes more and more cumbersome, okay, as the number of outcomes increases. So we have a mathematical rule that we can use here, right? Instead of drawing the diagram, we can do a calculation. So, as long as each stage is independent of the other, that is, the outcome of one doesn't influence the outcome of another, then the probability of a multi-stage experiment is the probability at each stage multiplied together. Okay, so let's have a look at an example and apply this. If I toss a coin 6 times, right, if I were to draw a tree diagram for this, then it would have to branch 6 times along the way, and I would end up with 2 to the power of 6, or 64 branches at the end, 64 different outcomes, which you would agree, I imagine, is somewhat cumbersome to fit in a page. But I know the probability of, let's say, a head on the first coin is 1/2. So the probability of 6 heads is 1/2 times 1/2 times 1/2 times 1/2 times 1/2 times 1/2. That's 1/2 to the power of 6, which is 1 in 64. So if I flip a coin 6 times, the probability that it lands on heads each time is 1 in 64. Righto. What about the probability of at least one tail? Now there is a clue here. There should be a little alarm going off in your brain. When you see that phrase, at least, we should be thinking, at least considering the possibility of looking at the complement of this event. Now, at least one tail, right, means one tail or 2 tails, 3 tails, 4 tails, 5 or 6. It doesn't mean 0 tails, right, or if you like, all heads. Okay. So, the probability of at least one tail is 1 minus the probability of the complement of that, which is 1 minus the probability of 6 heads, which is 1 minus 1 over 64 or 63 over 64. Okay, so that's much easier than calculating the probability of one tail plus the probability of 2 tails plus the probability of 3 tails and so on. Right, 1 minus the probability of the complement. Rightio. A fairly quick one today there, but the probability of a multi-stage experiment is the product of the probability of each stage. That's all we really need to take from there. Okay, if you've got any questions, please jot them down and ask me during class or send me a message. Other than that, I'll see you in our next video, which is probability tree diagrams. Thanks very much.